An incredibly important concept in programming is the concept of Boolean logic. Computers are electronic devices, and essentially each electronic component, whether it be in the processor or the hard disk or the memory chips, are essentially binary electronic devices, these tiny little transistors. They either have electric charge or they don't. Okay, and George Boole, working in Cork in the 1850s, came up with a logic which has been really useful in um, dealing with helping us to use computers. Okay, so this is binary logic. Something is either true or false. Something is either on or off. Something is either 1 or 0. Okay, so in Moodle, I've got a couple of examples here, so I'd like you to download those and put them inside a package in a project in NetBeans. Okay, so let's have a look at the slides. Okay, so Boolean logic is what we're interested in. We have what are called Boolean expressions. And later on, when we come to look at if statements, I'll talk about Boolean conditions. Okay, so we have comparison operators. This is just a very fancy way of saying we can check if the value of one variable is equal to the value of another variable. The value of one variable is greater than, less than, greater than or equal to, or less than or equal to the value in either another variable or an actual number itself. And then we have the Boolean operators. Okay, if something is true, then not that something is going to be false. If something is true and something else is true, both have to be true in order for the overall statement to be true. Or we could have something like if A is true or B is true, then the whole lot is true. Okay, and later on we'll use these Boolean expressions in conditions for our if statements. Okay, so if something is true or false. So we're interested in comparison. Okay, so here are our comparison operators. Okay, and essentially it basically breaks down to three. Okay, is something equal to something else or its opposite? Is something greater than something else or greater than equal to? Or is something less than something else or less than or equal to? Okay, and you can see this, the second one there is not equal to. Okay, not equal to. Okay, so just the exclamation mark and single equals. Now, if you remember, equals does not mean the equals on its own, just used once, does not mean equals. It means move. Okay, or it means assign. So whatever's on the right hand side of a single equals is moved into the variable on the left hand side. So it's really important. Okay, if you want to check for equality, check if something is equal to something else, you use the double equals. Okay, so 1 double equals 2, that is false. 1 not equal to 2, that is true. Okay, 4 greater than 5, nope. 4 greater than or equal to 4, yes. Okay, so greater than or equal to 4. So is 4 greater than 4? No, but 4 is equal to 4. So one of those two things is true. And similarly with less than or equal to. Okay, sorry, have I skipped one? Yes, okay. Okay, so page 5, in fact, let me just jump into the example. If we, sorry, Boolean logic examples pptx, okay, .java. So what I've got here is I've got some variables Boolean, slide 041, slide 042a, and so on. Okay, so what I'm doing here, just make that a bit bigger. Okay, what am I doing here? I am declaring a Boolean variable called slide04 underscore 1, and I am initializing it to the result of this Boolean expression on the right hand side. Okay, and essentially we're checking, is 4 equal to 4? That is either true or false. Okay, so if we come back up, oh, sorry, it's the wrong one. If we come back, if I run this, we come back up here. Is 4 equal to 4? Yes, it's true. So the Boolean slide 041 variable will store true. Okay, there we go there. And then if I put an exclamation mark in front of it, I am basically asking if it's not. Okay, so exclamation mark means not, and remember 4 is equal to 4, so the Boolean variable stores true, so not true equals false. Okay, but I've got the word not in front of it. Okay, so 4 is equal to 4, that means it's true, it also means it's not false. Okay, and then we can go through the other ones there. Okay, so 4 not equal to 5, that is true. 4 not equal to 4 is false. Okay, and so on all the way down through them. So have a look at those, experiment them with them, make up your own Boolean expressions and test them out to see does it all make sense. Okay, so make sure you're familiar with double equals, exclamation mark equals, greater than, less than, greater than equal to, less than or equal to, and then getting the inverse of them if you like, using the not Boolean operator as well. Okay, if we move on to slide 5, okay, you can see we've got two variables here, A and B, and we've got various expressions here. Okay, so I think I'm doing, okay, I'm doing one of these in the example I give you. Okay, this one here, I'm checking if that's true. So we're going to, if you remember from last week, we did the bracket first, 5 minus A, that's 3, times 5 is 15. Is that less than 7? No, it's not. So slide 5 should say false, which it does. Moving back to the slides. Okay, when we go to slide 5, we can see the answers are true or false. So just go in and adapt the code on line 43 and just use the various expressions there and satisfy yourself that they give true or false as appropriate. Okay, so these are what are called comparison operators. Okay, those 6. And then we've got Boolean operators, or logical operators. Okay, and essentially we've got 3 of these to concern ourselves with. Okay, if something is not something else. Okay, if something is true and something else is true. Or something is true or something else is true. Okay, so the and the or, these are, if you like, compound operators. 2 things are involved with that. 2 conditions. Either one could be true. For the double vertical line, if you're wondering how to make the double vertical line, on a typical keyboard, typical UK Irish keyboard, just use the vertical line. So shift and this key here, just to the left of a Z for most people. Sorry. Okay, so double ampersand means and. Okay, both have to be true. Double vertical line means either of the two conditions have to be true. Okay, so these are compound conditions. So three Boolean operators. Let's look at the possibilities. Okay, so with the not symbol or the not operator, generally we're talking about one condition. But we could have two. We could get complex, but more of that later on. Okay, so the not operator, if we have one input or one condition, if that's true, then not that condition is going to be false. Okay, so basically whatever's over here is the opposite of whatever's over here. So if x is true, not x is false. If x is false, not x is true. Okay, we'll look at some examples of these shortly. And we just do the double ampersand, the symbol above the number 7 on the left-hand part of a keyboard. Okay, so double ampersand, x is true and y is true. Both of those have to be true in order for x double ampersand y to be true. Okay, so first line here, both x and y are true, and that gives x double ampersand y true. Okay, and in the other three cases, both of them are not, both x and y are not true. Therefore, x double ampersand y, x and y are false. Okay, and then our third one for or, in this case, it's easier to get x or y true. Okay, because only one of them has to be true. And if both of them are true, we see that x or y is true. Okay, so only in the bottom case when both are false is x double vertical line y, x or y false. Okay, so exercise 2 on slide 11. You can see here, is 2 equal to true? Sorry, is 2 equal to 2? Yes. Is 3 greater than 4? No. So overall, number 1 is false. Number 2 is, that's true. Okay, when either condition is true, then or means the entire thing evaluates true. So even though 5 is not equal to 3, because that is true, the whole thing is true. Now, number 3 here, not, and then brackets, 3 greater than 4. So we're going to do the brackets first. Okay, the brackets are parentheses. Is 3 greater than 4? No, that's false. Not false is true. So 3 overall is true. Number 3 here, question 3. Okay, so part 4, the first half is the same as part 3, so which evaluates to true. 3 is not greater than 4, so that's false. Not false is true. Or 2 is greater than 3, that's not true, but the left hand side is true, so 4 is overall true. Is 3 greater than or equal to 0? Yes, it is, that's true in the brackets. The not, 5 is false overall. Okay, x equals 3. X is initialized to 3. Is x less than 5? Yes. Is x greater than 0? Yes. Both of those conditions are true in number 6. Therefore, the entire thing evaluates to true. Is x greater than 10? No. Is x less than or equal to 3? Yes. So overall, number 7 is true. Okay, so here are the solutions here. And then we can look, you can run the code here and check them yourself. Okay, and do that, and don't be afraid to experiment. Put in your own Boolean conditions.